locus of the centers of all circles which touch two given intersecting straight lines. So this question number 7 that we are doing now, this is somewhere closer to the earlier question we had done. We had done question number 3. So these two questions are a bit similar, but let's focus on this question now. Describe the locus of the centers of all circles which touch two given intersecting straight lines. So locus, as we have been discussing, locus is basically the path that uh, the path that is formed when a point follows a certain condition. So describe the locus of centers. So now in this case, what is the condition that the point is following? The condition that the uh, point is following is that the centers of all the circles which touch two given intersecting straight lines. So there'll be two intersecting lines like these. And now we want circles which will touch these intersecting lines. And then we'll have to look at the centers of these uh, circles which are touching two intersecting lines. So let us, we have more space here, so let us discuss this here. So, so this is a circle which is touching two intersecting lines. This is another circle which is not a very good looking circle. So this is another circle. This is another circle which is touching two intersecting lines. Yeah, this is the circle. This is another circle which is touching two intersecting lines. So it is touching here, it is touching here. This circle is touching here, this circle is touching here. The circle is touching here, here. Now I'll have to focus on the center of these circles. So this is a focus center, this is a center, this is a center. Now if you look closely, if I join these, if I join these, if I join these, you'll understand that basically this line is the angle bisector of this line and this line. Why? Because see, this radius and this radius, this distance is equal, and a tangent and a radius forms a 90-degree. Basically the perpendicular distance is the same. So here also the same condition is there. Here also the same condition is there. So basically this line is a sort of is not sort of, is actually the angle bisector of the intersecting lines. This is the same like we did before. This is the question we did here. So from these points also, and that is what I was saying. So I could have drawn a circle like this. I could have drawn a circle like this. These are the circles which are touching these two intersecting lines. And if you have seen this question, you would understand that these circles can be drawn here also. They can be drawn here also. So this straight line as well as this straight line. So basically we have pair of two straight lines which satisfy this condition. So this is one of the line. Let me use a thicker pen. So this is a line. This is one of the line which satisfies the condition. This is another line that satisfies the condition. So these two are basically the pair of angle bisectors of these two intersecting lines. Hope this is making sense. If it is not making sense, then try to look at this question again. Question number 3. Locus of point which is equidistant from two intersecting straight lines that form an angle of 60 degree. So basically, what we will write as an answer. So let us look at the answer. The answer would be locus of centers of all circles which touch two given intersecting line is the pair of angle bisectors of the angles formed by the two intersecting lines. So you will write the pair of angle bisectors of the angles formed by the two intersecting lines. Hope this is making sense. If you had question number 3, yeah, question number 3. So in question number 3 also we discuss something like this. Is the pair of angle bisectors of the angles formed by the two lines that bisect the 60 degree angle, supplementary angle. So This is the answer. Hope this is making sense. And let's do question number 8 now. Question number 8 is fairly simple. Describe the locus of a point which is at constant distance of 5 centimeter from a fixed point. This is fairly simple. So there's a fixed point and I need the locus of a point which is at a constant distance of 5 centimeter from a fixed line. So this would be any point, any point that would lie on this circle, any point that would lie on this circle would be 5 centimeter from the fixed point O. From the fixed point O. So the locus is basically the circle. Now, because we are in 2D, we are in two-dimensional in class 10th syllabus. So we get a circle only. But if you try to understand, just try to visualize, actually, uh, it won't be a circle. In 3D, it will be a sphere. So it's a sphere like this. It's a sphere like this. Where in the center, each point on the sphere is at a constant distance 5 centimeter from the fixed point. That is another way of looking at this. I'll do question number 9th also because question number 9th is also similar. Describe the locus of moving end of minute hand of a clock, assuming the clock is in the fixed position. So here also, same thing is happening like we did before. So this would be a clock. And let us assume this is a minute's hand. So the minute's hand is moving something like this. And if you trace the minute's hand, the edge of the minute's hand, it will form a circle. So again, the answer to this would be a circle. So for 8th and 9th, the answer for both 8th and 9th would be circle. Let's see how would we write this. So we'll write for question number 8 is a circle with center O and radius 5 centimeter, already discussed. Locus of the moving end is a circle with center at the clock center and radius equal to the length of the minute hand. So you can write in description also. This is a complete answer. So the locus of the moving end of a minute hand is a circle with center at the clock center and radius equal to the length of the minute hand. So I'm giving the answers also. I'll share this PDF also. You can have a look at the answers also that you can write. So 8 and 9 are similar. And question 7 was actually similar to a previous question that we had done. So we have done 9 questions till here and 4 more questions to do. And my take is that if you are able to do all these questions, if you have understood all these questions, you would have understood the concept of locus and you won't face any confusion whenever you're doing locus questions. Let's move to the next question.